Hello, ladies and gentlemen, and welcome back. We're on question number 13 of our 2016 Gauss paper. And what exactly have we got for question 13? A larger cube has a volume of 64 centimeters cubed. A smaller cube has edges that are half the length of the edges of the larger cube. What is the volume of the smaller cube? Okay. So there's sort of a fast way to do this if you are very good at geometry, if you know geometry really well, and some of the interesting things that can happen when objects are scaled up or scaled down. But there's a perfectly respectable, slow way to do the question as well. If you imagine a cube, how do you figure out the volume of a cube? Well, you take the side length, call it S, and you cube it. That's literally where the name comes from. It's length times width times height. They all happen to be S. S times S times S is S cubed. We could say, well, what do I have to cube to get 64? And we might know that. Or we might use our calculator to get that. Square root of 64 is 4. And then we imagine a smaller cube whose sides are half the sides of the bigger cube. So half of 4 is 2. So we're looking at a smaller cube that has length, width, and height of 2. 2 cubed is 8. So the answer is going to be 8 centimeters cubed. Okay? So that's the slower way where we actually work out all the sides and have to work backwards. What's the fast way? Okay, well, the fast way is kind of interesting, and it's useful if you do any sort of scaling geometry questions. So if I imagine a triangle, for example, okay, and I say triple all of the side lengths, I make a bigger triangle. It's proportional. Okay, it's just 3 times the side. So if this were an A, B, C triangle, we get 3A, 3B, and 3C. Now the side lengths have tripled. What has happened to the area? Well, it turns out the area, it's two-dimensional. It's a flat two-dimensional. It's got length and width, but no depth to this object. The area is multiplied by that same amount, that same scaling factor, 3, but we square it because it's two-dimensional. And the same thing works with a volume. If I imagine, say, a small cylinder, okay, and I blow it up by doubling all of its dimensions, every single dimension. So this, the height, what once was h is now 2h. The radius, what once was r, is now 2r. So this cylinder has been doubled in its length, its width, and its depth. How does the volume change? You'll get 2 times the volume, but not just 2, it'll be 2 cubed, because we're dealing with a 3-dimensional solid that has been scaled. Oh, the lengths have still doubled. That hasn't changed. And the surface area, area is 2-dimensional, will now be 4 times as much as it was for the small cylinder, but volume will be 2 cubed, or 8 times as much. Okay, so if we understand how this scaling works, 2-dimensional things, you multiply it by the ratio squared, or the scaling factor squared. How does that help us for this volume question? And once again, I'd like to remind you, you don't have to know this to do the question or to do well in contests, but this is a theme that comes up in more advanced contests, the sort that you might do in high school. So, if you want to sort of learn this special property now, that's fantastic. If you're happy with, well, I cube rooted the sides and I halved them and I cubed them, that's fine. It didn't actually take me that long. Okay, so you're not losing too much time. But if somebody came along and said, I've got a cube, and I created a brand new cube by halving each side, what's going to happen to the volume? Well, it's going to be 1/2 cubed the original volume, and that'll be 1/8 the original volume. And what was the original volume? 64. And 1/8 of 64 is 8. The same 8 we got up here. Okay? But I didn't have to figure out the side length. I didn't have to set up a brand new cube, and I didn't have to cube anything. Okay? And that's kind of cool. And as I say, it can help you out in more advanced contests, save you a bit more time. And actually, for something like the Euclid, which is a grade 12 contest, I've seen a question or two where you sort of had to know that, or you were not going to be able to get the answer. But that's way off in the future. For now, well, we've got our answer. It's C. So there we go. No need to worry. If you didn't follow that, that's okay. It's something to look into. But if you're just here for your solutions, 8. There it is, and we can move on.